Grade 8 Math, number 9.3a, Exploring Rotations. A rotation is a type of transformation that turns a figure around a given point called a center of rotation. The new image will have the same size and shape as the original pre-image, but the orientation changes. The way it's sitting changes. We can rotate the figure by a certain amount of degrees by rotating each vertex the same amount, or a vertex could be the point that's the center of rotation. And I'll show you. So here I've got some triangles on this graph. If we rotate it clockwise, the vertex that is up on the one that's on the right-hand side on the top there, I'm trying to put my marker away. If I rotate this, and this is the center of rotation, this black dot in the center, if I rotate this, well then our arrow is going to be down here in the bottom right, see? The center of rotation is in the center of the figure right there. If I rotate it again, now the arrow's in the bottom left corner. And if I rotate it a third time, it's right back to where it started from, see? But what if the vertex right here was the center of rotation? Well, it would start here, and it would rotate from this tip around this point, see? I could make it rotate around like this. See? So it can rotate with a center point in its same spot like that, or the center of rotation could be this tip and it could go all the way around like that and rotate. See? We could take different shapes and have them rotate around either in place, because the center of rotation would be in the center of them, or if the center of rotation was at the vertex, then it would rotate around like that, see? Like in this one, this triangle, if the origin right here at 0, 0 was the center of rotation, well then this triangle would slowly rotate like this, see? Then it would rotate like, oops, I lost my tape here. Then it would move like this, see? And then it could rotate again like this, see? And then I could put it right back here to its original place. So that's rotation. It could either be in the center of the figure, or it could be one of the vertex points. See? The vertices. Now, a square is 360 degrees, because each corner is 90 degrees inside. If we rotate the square by 90 degrees, it's still going to be the square. See? It doesn't even look like we moved it. See? I could rotate it 4 times, and it would go this point would go 360 degrees around, because it's got 4 sides. This triangle, interiors of triangles have 180 degrees inside. Each interior angle is 60 degrees in this triangle. So if I rotate it 1 time like this, because it's got 3 sides, if I put a little dot here, we'd be able to follow the dot now to this point and then back up again like I did with my pink one, see? So rotating is spinning around, and if this was his center of rotation, right here at his waist, he would just keep flipping around like that. If his center of rotation for an ice skater is right down the center of his body like this, well then he would spin around this way, right? You've seen ice skaters do that, right? If this red circle is the center of rotation, well then our hand rotates around, and this is the center of rotation. That's the point it's going around, see? Does that make sense? So now you know reflection. Reflecting is, it's just flipped over, right? And it's the same size and same shape. It's just got a different orientation. Translating is like sliding on ice, and rotating is spinning around a center of rotation, okay? We're going to move on, and we're going to talk about the properties of rotations in the next video. After that, we're going to talk about graphing, and eventually we're going to start talking about doing this algebraically, okay? I'll see you next video. Bye.